Hello. In this video, I thought that we would be finding the indefinite integral of this kind of interesting looking function here, x over the square root of 4 plus x squared. And to do this, we're going to be practicing our U-substitution. And U-substitution is so awesome. You're going to love it so much. Okay, so let's take a look at our function here. With U-substitution, you tend to be looking for a function that you want to simplify, or a fraction of this function that you want to make simpler because you can't take the integral, or the indefinite integral in this case, as it is. And what bothers me most about this is this 4 plus x squared here under the radical. So I'm just going to say, hey, let's take 4 plus x squared. Let's just say that's equal to u, right? Let's just simplify this. Let's say 4 plus x squared is equal to u. And I should probably write that the other way around, that u is equal to 4 plus x squared. And hence we can find the derivative of u with respect to x is going to be equal to 2x. So we can say that du is equal to 2x dx. It's sort of multiplying both sides by dx, sort of not, but for our purposes, that does accurately represent what we're doing. Okay, so now we have these two kind of like rules here for our substitution. Now we just need to find ways to put them in the function. Oops, I outlined the wrong ones. We've got this one to worry about, and we've got this one to worry about. So is there any way, we've already found this, right? This is all the way down here. Where's our 2x dx? Is there any way to connect that? Well, we have an x dx here, and that arrow is going to make things really confusing. But is there any way to make it a 2x dx? Well, yeah. All we need to do is multiply by 2. All we need to do is say, hey, let's multiply this by 2. As long as we divide by 2 at the same time, it doesn't really matter. And that's true. So now we can say that this whole thing is going to be, and let's do a different function. I'm going to do, what am I going to do? Let's do purple. Yeah, purple will probably show up on the video. And that's going to be 1/2 integral of, well, we've got 2x dx. We know that that's going to be du up there divided by the square root of 4 plus x squared. That's going to be the square root of u over the square root of u. All right, and we can simplify this a little bit. Just make this a little bit prettier to look at. 1 over the square root of u du, or even easier, 1/2 times the integral of u to the negative 1/2 du. Okay, so how do we evaluate this? Well, we can just look at the anti-differentiation power rule, right? That's basically the power rule for integrals. All we're going to do is do, let's switch colors for this. We're going to do +1 up in the exponent, and then divide by that new value. And I'm sure you remember that, right? So all we're going to do is say that this is going to be equal to 1/2 times, we're actually getting into the integral now. We just need to take u, we need to add 1 to this 1/2 here. So we're going to have u to the 3/2, but then we divide by that new value there. So we divide by 3/2, we're going to get 2/3. And you can take the derivative of that if you're not, oh, I'm sorry. I got completely messed up. When you add 1 to negative 1/2, you just get 1/2. When you divide by that, you get 2. My mistake. And if you take the derivative of that, now hopefully it's clear that we have our answer. 2u to the 1/2, just multiply, to take the derivative, just multiply by the exponent, 1/2, that's going to cancel out the 2. Then subtract 1 from the exponent, we have our function here. Okay, so now that's going to, our 2's are going to cancel out. We're going to get that our integral is u to the 1/2. And that's kind of neat. That's pretty simple. That's just the square root of u. But what was u, after all? Well, u is 4 plus x squared, so why not just use that, right? Because, I mean, it would be nicer to have this in terms of x. So I'm going to use that. I'm going to say that our answer is going to be the square root of, what's u? 4 plus x squared. And this is indeed going to be the antiderivative of our original function. If you don't believe me, for whatever reason, maybe you just dislike me, I don't know. I don't know why you have so much doubt in your mind, but I can show you that this is indeed the antiderivative. If we just take this function here, and we take the derivative, we should get our original function. Let's say that this is f of x, and that's going to be square root of 4 plus x squared. I'm going to kind of rush through this a little bit. We just take the derivative. We're going to use the chain rule to find that f of x is equal to, right? Look at the outside function first, the square root. You probably remember that the derivative of that is going to be 1 over 2 times the square root of our function. Then we have to keep our function in there, multiply that by the derivative of the inside, which is going to be 2x. And we're going to get that our f of x, which is, of course, the derivative of that function, big F of x, capital F of x, is going to be the 2's cancel out. It's going to be x over the square root of 4 plus x squared. If that's unclear, I recommend that you look at videos on the chain rule, because that's all we're doing here. This is just one quick way to show that we did indeed take the indefinite integral correctly, because when we take the derivative, which is kind of another topic that is for other videos, we do indeed get the answer that we do indeed get the function that we began with, which indicates that we found the correct answer. So in closing, we know that the indefinite integral of x over the square root of 4 plus x squared dx is going to be equal to the square root of 4 plus x squared. And that's kind of neat. I hope you enjoyed, and thanks for watching.